Welcome, Eduvo students. I'm thrilled to be guiding you through section 14.2 of your textbook today, focusing on sociotechnical resilience. As software engineers, it's incredibly easy to fall into the trap of thinking we can solve absolutely every problem just by writing more code. But today, we're going to learn why that's just not true. We'll see why well-trained, adaptable humans, rather than endlessly complex code, often provide the ultimate defense for our systems. So grab your notebooks, get comfortable, and let's explore how we actually build truly resilient systems.
All right, here's our game plan for today. We're going to cover sociotechnical systems, characteristics of resilience, approaches to human error, the Swiss cheese model, optimization versus resilience, and we'll wrap up with a solid exam focus. Let's jump right in.
Section 1. Sociotechnical systems.
To build dependable software, we have to look way beyond the hardware and the lines of code on our screens. So let's start with a crucial definition. What exactly is a sociotechnical system? Well, it's a system that includes non-technical elements like people, operational processes, and organizational policies, right alongside the technical components like computers and software. The really important takeaway here is that operators, managers, the company's culture, and its procedures aren't just external factors. They are inherent parts of the system architecture itself. You literally cannot separate the software from the people using it.
Let's map this out visually. Notice how the technical computer systems, labeled S1 and S2 down at the bottom, sit inside a much broader socio-technical system, labeled ST1. Now think about who sits right above those technical systems. It's the operators. If system S1 fails, those human operators in ST1 are the ones who detect that failure. They are your very first line of defense. And if the operators can't contain the problem, the failure moves up to the managers at the broader organizational level. People are literally wrapped around the technology to manage the unexpected.
So, time for a quick micro recap. Keep this front of mind. Resilience is often so much easier to achieve at the human level. Flexible humans dealing with unexpected events provide far better resilience than rigid, overly complex software trying to anticipate every possible thing that could go wrong.
Section 2. Characteristics of resilience.
Now let's see how this translates into actual organizational behavior. We're going to look at Eric Hollnagel's framework for how modern organizations need to behave to stay resilient. What's super interesting here is the overlapping, continuous nature of these four characteristics. Resilience isn't just a one-off checklist. It's a constant, ongoing cycle.
Let's break down each of these four interconnected concepts. First is respond. An organization has to adopt its processes quickly the moment a threat is detected. Second is monitor. You have to keep a constant, watchful eye on both the external environment and how your employees are actually behaving day to day. Third is anticipate. You can't just focus on today, you must look ahead. Think about how new innovations, like employees bringing wearable technology into the office, might compromise your current security protocols. And finally, learn. This one is vital, and it's a common misconception that we only learn from mistakes. Don't just investigate failures, investigate your successes. Figure out exactly how human operators successfully navigated a crisis so you can spread that good practice everywhere.
Micro recap time. To be truly resilient, an organization must do four things continuously: respond, monitor, anticipate, and learn. Make sure you've got those four jotted down.
Section 3. Approaches to human error.
We've established that humans are critical for resilience. But let's face a difficult reality. Humans are fallible. People make mistakes. How we as engineers choose to view these mistakes changes absolutely everything about our system design. There are two main ways to look at this. The first is the person approach. This blames the individual. It assumes the error happened because someone was careless, and the fix is to punish the operator. Then we have the systems approach. This accepts that human fallibility is just a fact of life. People mess up when they're tired, under pressure, or, very often, using poorly designed interfaces. Instead of pointing fingers, the systems approach asks, why didn't our system defenses catch this? Let me be crystal clear. The systems approach is the correct engineering mindset. Punishing people doesn't improve long-term safety, building better systems does. Here's your micro recap for this section. Good engineers do not punish fallible human operators. They assume errors will inevitably happen, and they focus all their energy on designing socio-technical barriers to catch those errors long before a disaster hits.
Section 4. The Swiss cheese model.
Okay, pay very close attention right now because this next concept is absolutely crucial for your upcoming exams. We're talking about James Reason's famous Swiss cheese model. But before we look at the model itself, we need to define two things. First, latent conditions. Think of these as shifting vulnerabilities hiding within your system's defensive layers. Second is active failure. This is your trigger event, like a targeted cyber attack or an operator clicking the wrong button. Keep those two terms in mind.
So imagine every single layer of defense in your system, that includes software checks and human checks, is a slice of Swiss cheese. The holes in the cheese represent those latent conditions or vulnerabilities we just talked about. Because systems are dynamic, these holes are constantly moving around and changing size. A catastrophic system failure only happens when an active failure, like that operator error, aligns perfectly with the holes across every single defensive layer. So how do we engineers stop those holes from lining up? First, we simply increase the number of defensive layers. More slices of cheese mean it's statistically way less likely for a straight path to open up all the way through. Second, we make sure the layers are diverse. If two layers use the exact same software logic, their holes will be in the exact same spot. You want diverse checks, like having a human double-check an automated output. And third, we try to reduce the chance of the trigger event happening in the first place, maybe through better user training to minimize those active failures.
Let's lock this in with a micro recap. James Reason's Swiss cheese model teaches us that all defenses have moving vulnerabilities, the holes. If a trigger event perfectly aligns with those holes, the whole system fails. Diversity and depth in your defensive layers are your absolute best protections.
Section 5, Optimization versus Resilience.
In modern business, there is a constant, built-in tension between operating at maximum efficiency and maintaining system resilience. Companies absolutely love efficiency, which falls under process operation. They love optimization, type control, and automation, because, frankly, it saves them money. But true problem management, which gives us resilience, requires process flexibility, adaptability, and collaborative checking. When a business aggressively optimizes by automating everything and firing redundant staff, they are actively destroying the exact redundancy and information sharing they need to survive a crisis.
The crucial point to remember is that process automation removes the flexible human problem solvers you desperately need during unanticipated failures. Think about an emergency control room. If the highly automated network goes down completely, what happens? Well, the human operators pull out their personal cell phones and start coordinating manually. The rigid automation failed, but the adaptable humans improvised to keep a critical service running. If you had optimized those humans out of a job to save a few bucks, the entire system would have totally collapsed.
Quick micro recap here. There is a direct trade-off between business process optimization and system resilience. Over-optimization often completely destroys resilience because it removes the adaptable human operators who act as your safety net.
Section 6, Summary and Exam Focus.
We've covered some fantastic ground today, so here is your final checklist. If you can confidently do these 5 things, you are fully prepared. Number 1, define a socio-technical system. Remember, it's not just tech, it includes the people and policies. 2, list Hollnagel's 4 characteristics: respond, monitor, anticipate, learn. 3, contrast the person approach with the systems approach to human error, and know exactly why the systems approach is better. 4, be able to physically sketch and explain James Reason's Swiss cheese model. And 5, explain the tension between business efficiency and system resilience. Master these, and you are going to ace this section.
I want to leave you with a provocative question to ponder before your next lecture. Is your best defense against a cyber attack really just another line of code, or is it a well-trained, adaptable human? Think about how human adaptability connects to everything we've explored today. In our next session in the software engineering program, we're going to look at how we actually design resilient architectures to support these human operators. Until then, keep studying, keep questioning, and I will see you next time.